Okay, welcome back. Today we're working on the study guide, and we finished the unit on sound and light. So this is a review before you take the test. I wanted to go over this with you. So let's get started. Used to locate objects underwater by the reflection of sound waves. There's three ways that sound waves are used to find things. There's echolocation, which is used by animals. There's sonar, which is used underwater. And then there's ultrasound, which is used by doctors to look at images inside the body. So this first one that's used by humans to find objects underwater is sonar, and that's M. Finding objects by emitting sound waves and interpreting the reflected sound used naturally by humans, that's echolocation. So that's I. The way the brain perceives the intensity of sound, the way we refer to it in everyday speech, is loudness. So that's L. Change in pitch caused by the motion of either the sound source or the receiver is the Doppler effect. And what happens there is the sound waves in front get bunched up as you move towards the sound, your own sound, and as you move away, the pitch is lower. The amount of sound energy that flows, well, it gives us the clue right here in number 3, the way the brain perceives intensity of sound. Okay, this is intensity of sound. The study of sound is known as H, acoustics. Caused by a reflection of a sound wave is an echo. Measured in hertz is frequency. It's the number of wavelengths per second. When light hits a rough surface and bounces off, there were two kinds of reflections. There was a regular reflection, which is off of a smooth surface, and then there was a diffuse reflection where the light gets broken up. That's J. And then the first multiple choice question, when electromagnetic waves have the longest wavelengths and the lowest frequencies. The longest ones would be the ones that are as big as buildings, B. Okay, this is page 2 of the study guide. Visible light has a frequency higher than. All right, so visible light is on the spectrum of Roy G. Biv: red, orange, yellow, green, blue, indigo, and violet. So the lowest frequency light is red, and the highest frequency is ultraviolet. And it says visible light has a frequency, visible light has a higher frequency than. So that means it's just above. Well, infrared is just below visible light, so visible light would have a frequency higher than infrared. Remember, we see the reflected color. So a blue shirt looks blue in white light because blue light is reflected. Electromagnetic energy waves can transfer energy without, they can travel through the emptiness of space. So they do not need a medium. So it would be A. All of the following would cause a diffuse reflection, except, remember, reflections are either diffuse, which is broken up, or they're regular from a smooth surface. So we're looking for the one that would be smooth. The leather's rough, fabric is rough, the glass is smooth, so that would cause a regular reflection, and then brick is rough. Wax paper is, remember, there's 3 things that can happen to light. Things can be transparent and all the light goes through, translucent and some of the light goes through, or opaque and none of the light goes through. Wax paper allows some of the light to go through, so it would be translucent, A. If light waves change speed when they pass from one medium to another, okay, the change of speed is not reflected, that's when it bounces off. It is refracted, that's when it changes speed and is broken up. We didn't say anything about it being separated, and diffracted is when it bends around a barrier. The range of electromagnetic waves is placed in a certain order called the A electromagnetic spectrum. Plastic wrap, so like when you go to the grocery and you see food wrapped in plastic wrap, it's clear, like, meat that's wrapped in plastic wrap, meat area of the grocery store. So plastic wrap would be D, transparent. All the following are part of seeing yourself in the mirror, except, well, the first thing that would happen is B, light reflects off of you. And then it's going to travel to the mirror. So light from you hits the mirror. And then it's going to bounce back and reflect to your eyes. So light from the mirror hits your eyes. So the last thing, D, light from the mirror hits the wall, has nothing to do with you seeing yourself in the mirror. And which of the following media can sound not travel through? Sound cannot travel through empty space, which is B. A sound needs, it's a mechanical wave and it needs a medium. We know it can travel through air because you can hear people speaking in the air. We said it travels very fast in metal, and then dolphins and such use echolocation and sounds in water. All right, page 3 of the study guide. Which of the following temperatures would sound travel the slowest in? So one of the first exercises in this unit was you graph the speed of sound. And sound travels faster as the temperature increases. So it would be the lowest temperature, which would be -5. What type of scanner is used for airport security in the diagram? Well, ultraviolet is like those tanning machines, so this is not bad. Fluorescent light bulbs are like the light bulbs in the classroom, so it wouldn't be that. Gamma radiation is very dangerous. An X-ray would be what they're using. Use the diagram of light, of the reflection of light, to identify 1 and 2. Line 1 is also known as, well, okay, so it shows this. Line 2 is coming in, and that would be the incident ray. And then line 1 coming out would be the reflected ray. So it's not scattered and reflected, tilted and normal. Incident ray and normal, that's not correct. Reflected ray and incident ray. Well, 1 is the reflected ray and 2 is the incident ray. So that looks correct. Reflected and scattered is not correct. So it's C. When sound travels through air, the air particles, well, they vibrate parallel. Remember we said in a compressional wave, the particles move parallel to the direction of the wave. So vibrate, but not in any fixed direction. That's not true. Perpendicular to the direction of the wave movement is a transverse wave. Vibrate along the direction of the movement of the wave. That's the same as parallel, and do not vibrate is wrong. So this is C. Which of the following media does sound travel the fastest in? A balloon filled with helium would be a gas, and sound travels slow in a gas. It would travel faster in the water. A hollow wall would be a gas, and a solid block of glass is the one with the most high density, so it would be C. If sound is high-pitched and loud, the sound wave, well, high-pitched is high frequency, and if it's loud, it has a high amplitude. So the first one, A, high frequency and high amplitude, is correct. When your mother tells you to turn down the radio, she is asking you, well, the frequency would be the pitch. So we know that A and B aren't right. Raise the amplitude would be putting more sound energy, so that's not right because she said to turn it down. Lower the amplitude would be lowering the energy in the sound wave. The number of cycles of waves passing a particular point per second is the definition of frequency. Wavelength is from any point on the wave to the next one just like it. The pitch of sound would be how high or low, and amplitude is the energy. Sound with frequencies higher than 20,000 hertz are above what we can hear, and they are called not sonic booms. That's what an airplane does. Sub means below. Supersonic means how fast the planes can travel. So it's B, ultrasonic. Just like ultraviolet is above what we can see. So it's the ultra. Which of the following do acoustical engineers not deal with when designing a space? Absorption would be true because they want the sound waves absorbed. Reflection was causing the reverberations. Reverberations are definitely part of it. Ultrasounds are sounds that we cannot hear, so they would not be concerned with that. Okay, this is the third page of this is the fourth page of our study guide. If you pass a building with a siren sounding, as you move away from the building, the sound will have a lower pitch. Particle of electromagnetic radiation, protons in the nucleus of an atom. The nucleus of an atom doesn't move. Broadcasting has nothing to do with it. It's C, a photon. These can be used to destroy diseased tissue in a patient. Well, infrared is heat. Fluorescent is like the lights in the room. Gamma radiation can destroy cells, and X-rays are used to detect bones. So it would be D. Which light wave has the longest wavelength and the lowest frequency? Well, it'd be the first one, red. Which light wave has the shortest wavelength and the highest frequency? It would be the last one, B, violet. Which action must occur first in the process of producing electromagnetic waves? An electric field changes. All waves are started by something that vibrates. The charged particle vibrates. The magnetic field changes, but the field around the charged particle vibrates. It's the charged particle vibrating. The reflection of light waves from a smooth surface is called a regular reflection. Diffuse is when it's broken up. Mirror reflection is, the choices are either diffuse or regular. Mirror and irregular are not choices, so it's D. If light waves change speed as they pass from one medium to another, the light will be refracted. Diffused means it's broken up like the reflection. Reflection means it bounces back. Separated is not even something we talked about. Strawberries reflect light. Strawberries reflect light waves of which of the following wavelengths? Remember, the color we see is the color reflected. Strawberries are red, so they reflect red light. Which is most important source of electromagnetic waves for the Earth? The moon doesn't produce light. Humans don't produce light. Fire does, but it produces some radiant energy. The sun, obviously, the source of energy for the producers is the most important one. Okay, that finishes our review of the study guide. I hope you do well on yours and look it over. And I know if you do the study guide and pay attention, you'll do a great job on the test, and we'll see you soon.